Hello everyone, so this is me Rudrak Pathro and today we'll solve the problem called spiral matrix 2. So given a positive integer n, generate an n cross n matrix filled with the elements from 1 to n square in the spiral order. So spiral order just means you start from 1 over here, go right until you can no longer go rightwards, and then you go switch directions and go bottom, or towards the bottom and say then you go left and then top and then right again. So you go spiraling down instead of center, and you do this until you fill the entire board. So the board will be a square board, and you just like seems like we have an input of n over here, and we have to print out the matrix, or like we have to provide the matrix itself. Okay, so we need to create a matrix first, so let's just do that. Vector of int. So this will be our matrix. The size of this will be n. So row and column wise, both ways it says n. um, let's initialize everyone with 0. 0 basically just means like this is not yet initialized, because nowhere the 0 will be coming in this after the initialization or the creation of the matrix. So this acts like an indicator that like the cell is not yet processed. So you can also keep a count, like the number which is going to be placed. So count can be 1. We can say like while count is less than equal to n square, so this will be going on. So at the end we will put count 9 over here, and then we'll finish the while loop, and then I will return the matrix. So now we just left to actually provide the position and put the value of count in that. So I need to also do count plus plus, like, and now we have to do the matrix of some x comma y. Now this should be equals to the count. Yeah, so how do we find the x comma y, and how do we change the x comma y to a new location? Well, you can see like the direction is currently there, which is saying like how the x comma y will change, and the direction changes on basically like two conditions. When it is outside the boundary, like currently we have direction of right, so it's this time from this 3, if we go towards the right, we will see that we will go outside the boundary. So this time we need to change the direction. Also, like if you look at this 8 over here, we have the direction currently as up, right? If we try to go up, we will actually like our rewrite this value, right? So this is already there, so it's not 0, so that means we need to change our direction. So let's keep an account of the direction we have, so dir, and this can be 0, representing the angle, or we can have like a schema of something like the direction, like pair of int, and this will be like the shift in the xy values. So we have the x as a state currently 0 0. Initially we start from 0 0, so this is the shift now, which is gonna be like right means let's shift the y value as 1, so y becomes plus 1, j or x remains the same. The next is from right to downward, so this is 1 comma 0. Then we have left, so 0 comma minus 1, and then we have top, so this is gonna be minus 1 comma 0. Okay, so this is the shift. So how do we use the shift? Well, we see we want to figure out first the new location of x and y. So we can say the new x equals to x plus shift of dir, which is gonna give us the pair, but now we want to put the first value and then we will be doing the same thing for our y, or the new y. Now this will be the second value. So we found our new x and new y, but if this new x and new y actually goes outside or the value, so we just discussed the conditions before, so let's just write down. So new x is, say it's outside the boundaries, so it will be like less than 0, or new x is more than equal to n, or we have something like this, right? So the last condition is like we have the matrix, the value of new x and new y in the matrix. So we can access the matrix only after this new x and new y is inside the domain of the matrix for the positions. Okay, so this value is already occupied. So occupied, if it is occupied, then it will be more than 0 or not equal to 0, whatever you wish. So if this is the case, we just need to re-update our direction and also re-update our x and y. So direction plus equals to 1, the direction is mod equals 4, and then we have to do the same things. So let's copy, we don't need the int. So now the new x and y should point to the next valid location. Well, we just now leave is like x should be our current count starting with 1. Okay, so now x should be our new x, y should be our new y. Let's do count plus plus in the same line. Okay, so let's run this. Seems about right. So yeah, so it's accepted. Looks about that's the only thing that we could do about this problem. Like time complexity, whatever you do, you have to create a matrix, so it's obviously n square at least, and everyone will be doing in n square. So this is about time complexity, and space will also be n square because of the matrix over here. So yeah.